Hello, I'm Andy Kirby, an applications engineer at Keithley Instruments, a Tektronix company. Today we're going to be determining the average current of an IoT device using the Keithley DMM7510 in order to better understand the power consumption and feasible battery life of the device. Because these types of devices have multiple quickly changing states of operation, each consuming a different level of power, it is important to have an instrument that is able to measure both very low and high current. An IoT device can draw as low as hundreds of nanoamps in sleep mode, and up to a couple of amps in transmit mode. This is no problem for the 7510 motor, which has a dynamic range of 1 picoamp to 10 amps. Another challenge in capturing current characteristics of these devices is the speed that they change states, some only lasting tens of microseconds. We will need an instrument capable of capturing rapidly changing load current waveforms. Because the 7510 has a sample rate of up to 1 million samples per second, a very clear and detailed waveform can be found, exposing the current profile and allowing you to identify any power wasting problem areas such as unwanted transients. The large dynamic range and the high sample rate, coupled with an internal buffer capable of storing 27.5 million readings, make the 7510 the ideal instrument for characterizing average current of an IoT device, and doing so over the duration of a typical use case. I will now show you how this can be done using the DMM7510, the Keithley 2281S precision power supply, and a Bluetooth low energy tracker. With the device attached to this test fixture and the power supply set to source 3 volts, we will now change the function to digitizing current. We'll change the trigger to manual trigger. Then we'll go in the reading buffer, change the capacity to 1 million to store all of our data. We'll clear out the data that's in there already. We'll go to settings, change the sample rate to 100,000, and the count to 1 million. This will give us 10 seconds of data collection. Next, we'll go to the graph view and hit trigger. Looking at the graph, it is clear that the current drawn by the device is different at each state of operation. We can see here that the device goes from unpaired to paired to alerted, then back to unpaired. Because the 7510 was able to capture all the various current values of this complex waveform, we can find the average current drawn from the power supply by swiping along the bottom of the screen to the cursors page, adding vertical cursors across the area of interest, then swiping back to vCursor stats, and giving us an average current of 4.869 milliamps. These average current measurements are crucial to any design engineer concerned about the power consumption of their circuit. Using the information obtained on the DMM7510, an engineer can gain valuable insight into the possible battery life of their device. If they find that their circuit consumes more power than expected, it might be necessary to use more efficient components or a larger, higher amp hour battery. Power consumption is of concern for the design of all IoT devices, and the Keithley DMM7510 is the ideal instrument for analyzing it.
Find out more at Vicom's website.